right, thank you for the intro. Hey everyone, my name is Kendall, and as soon as we get there we go. I am going to tell you a little bit about a world that I hope we all eventually live in, which is cross-chain without bridges, and we'll talk about why. So this probably is not news to anybody in this particular room, but cross-chain DeFi is becoming increasingly important. Certainly helps we're in a positive market, but nonetheless, bridge volume since November has increased pretty substantially. On average, I'd say it's pretty close to 3 or 4x. And we've also seen cross-chain swap volumes increasing dramatically as well in a pretty similar fashion. I think based on where it seems like things are going, this is only going to increase. And as great as this is, one of the issues is that we are mainly using bridges to enable these cross-chain patterns, and they have a lot of limitations. I think they're really not enough of a key piece of this kind of chain abstraction stack to actually enable the use cases we're looking for. So why is that? Well, the first reason, as many of you have seen time and time again, is that bridges are really hard to build. The fact that they've been hacked is not because they're built by people who don't know what they're doing. They're built by some really fantastic teams who are extremely talented. There's just a really large attack surface for building bridges. It's difficult, and that's why we see even some of the best teams having exploits. The other really big issue is that a lot of chains you can't build bridges to. You cannot build bidirectional bridges to chains that don't have smart contracts without using some pretty wonky design patterns. And even in the smart contract chains that we do have, there really aren't any bridges that go to every single chain. So what this means is that users are forced to use different bridges to go between different chains, which leads to a really inconsistent UX. So if you use different bridges, what that means is you're going to deal with very, very different bridging speeds. Best case scenario, you're looking at like high seconds to minutes. Worst case scenario, you're looking at hours. And if you're using kind of native bridges to some of the optimistic rollups, you'll even be looking at days or like a full week. The other issue is that each of these bridge standards tends to introduce its own version of an asset. What this means is that if you use one bridge, you'll end up with one version of the same asset. If you use a different bridge, you'll end up with a different version, which means that you might end up with the wrong version of the asset that you're actually trying to use. And you go try to swap this and realize, oh, there's not much liquidity for the bridge version of the asset that you have, so now you have to try to get to the other version of the asset, which is just a really painful experience, and there's not very many good solutions with bridges. And then the final, not so great part of UX is having to deal with gas tokens on all the different chains that you're interacting with. Many bridge providers are now trying to provide solutions for this, and there are some pretty good approaches, but it's overall just a very, very inconsistent and frustrating experience. Not very good if you're looking to abstract away the chain from users. So fortunately, I think we do have a really interesting new addition to the kind of options and toolkits that developers can take advantage of in the form of programmable MPC. So many of you are probably familiar with using MPC wallets. Coinbase wallet recently added this kind of solution to their stack. Fireblocks or a lot of the kind of more institutional-facing products have been using this for a while. But what we're introducing, and what fortunately several other teams are also introducing and noticing, is that you can actually use MPC as a core building block, make it programmable, give access to developers to actually kind of determine when or where to sort of issue these signatures, and then even decentralize the sort of key shares that these different MPC nodes are operating and create some really robust systems. So there's two main kind of approaches to programmable MPC thus far. The most common that we've seen that's been in production for a minute now is what I call deposit-based. And this is basically using MPC at the chain level to create kind of deposit addresses, and then essentially have like a native wrap version of an asset. You can probably even add Avalanche on here as one of these examples, but Definity's been doing this to have kind of like Bitcoin on Definity and Ethereum on Definity using what they call chain key signatures. We've seen some swap protocols like Thorchain and Chainflip, and then even some like pure bridges like Axelar. But I think what's really interesting is the other approach that us in the Near community and also the Lit protocol team have been taking, which is actually allowing each user account to use this programmable MPC to then directly maintain their own sub-accounts on any number of chains. And where this gets really interesting is when you think that can actually, those accounts can also be smart contracts. And this opens up an entirely new design space. So what are some of the key advantages of programmable MPC? One of the main ones is that you can actually support every single chain, pretty much. As long as you can support the elliptic curve that the chain is using, and you can actually design an API that's flexible enough to basically support smart contract chains, non-smart contract chains, whatever people are essentially building. You also get instant support for new chains. As long as, again, you support, if they're an ECDSA chain, as long as you support ECDSA, or whatever it is that they have support for, out of the box, developers can immediately start building this. They don't need to wait for you as like the bridge team to go and deploy a smart contract or like deploy some kind of integration with that chain. And since we see new launches pretty much daily or even hourly now, this is actually pretty important. And the final benefit that I think is potentially easily overlooked is that you can really standardize the user and the developer experience with this. And what I mean is that in the previous example, we talked about having to use different bridges, and maybe one takes an hour, maybe one takes a day, maybe one takes a week. With this, the cross-chain interactions will take the same amount of time. And I think that's how we get to true chain abstraction, is so that you don't actually notice that your experience changes radically when you're moving between chains. Obviously, there are some things you can't get around. There are different confirmation times and things like that, but where we can abstract away that experience, I think it's quite key to get to the UX we design. So we'll dive a little bit more into what exactly we're building in here and why we think it's really a compelling version for Kendall MPC. So you might have seen Ilya use this same slide earlier. So basically what we are doing is launching a product called Chain Signatures, essentially threshold signatures that are controlled by near accounts, and this can include smart contracts. So it's going to be a really, really simple API. It basically just takes in a payload. This payload will be the raw transaction that you're trying to sign, which can be for whichever chain. And then we'll take in kind of like if you've used like an HD wallet or ledger, you've seen you can pass in like a different path and kind of generate different end accounts. This means that these users can then maintain like sort of many different versions of their account. So they can sign for sort of different addresses effectively. And then finally, you can pass in the key type. So if you're trying to use Ethereum, it's ECDSA. If you're trying to use Solana, Cardano, Near, etc., ED25519, and as we continue to add more key types, you'll be able to pass those in. So to walk through a little bit of an example here, you have the Near account, which initiates a signature. They'll include that path, they'll include the payload, like the transaction they're trying to sign, and they'll essentially, after they initiate the signature, the MPC nodes will pick it up. They'll each sign with their respective key shard. They'll sign this payload, and they'll pass back that signed transaction to the user or the front end, and then that'll end up being relayed to the destination network. So you can see here, you can sign use this Near account to sign for any basically blockchain that's under the sun. And to walk through a different example that uses a product we're also launching called the multi-chain gas relayer, similar type of setup, except this time the MPC nodes will actually kind of pass the signed transaction, or at least make it available to a network of relayers, who will then take payment from you in some token on the Near side. A great example of this could be Sweat, as Oleg demonstrated earlier, or USDC if you want something that's completely non-volatile. And then these relayers will be able to fund the destination account with some gas tokens, kind of just in time. And then you'll be able to send your signed payload kind of right behind it, which in some cases could even be in the same block, so that you're just sitting there with USDC, but you're paying for transactions in Bitcoin, in Ethereum, in Sol tokens, in Atom, and whatever it is. So most importantly, what are the different use cases? So I think there's quite a few here because it is a very broad design space, and I'm really excited to see what developers come up with as they get access to this. Some of the areas we're particularly excited about, not surprisingly, as we talk about cross-chain without bridges, I think being able to build these DeFi applications that are spanned across different chains without needing bridges is really powerful. Maybe equally or even more exciting is the ability to build DeFi applications for non-smart contract chains like Bitcoin. The reason this works is that, for the most part, the key building block of DeFi is escrow accounts that are programmable and have some kind of rules they follow to determine when to basically send assets to one account or send assets to another account. And so because we can have smart contracts on Near that can be immutable, not have any sort of way to change these contracts, so they are safe DeFi protocols, and they can sign transactions using these chain signatures on, say, Bitcoin, then the smart contract on Near can actually maintain basically the state of the DeFi application for these kind of Bitcoin-only applications. And we'll actually walk through an example of that in just a second. And then one of the other areas that's I think quite powerful and is going to get a lot of attention is kind of multi-chain account abstraction, which that's actually a pretty good example of what Sweat showed. That's basically multi-chain account abstraction, and we'll be showing a lot more of this in the future. So zooming in a little bit more on kind of the bridges cross-chain DeFi, just to give you guys some ideas of what it is we're looking into. Native swaps we think are going to be quite important. You can go basically from any asset on any chain to any asset on any other chain. So that's like Bitcoin, ETH, XRP, Solana, whatever it might be. One of my personal favorite cases is building cross-chain lending, basically allowing users to use any asset on any chain. And this can even include assets in unique states. Like you could have actually like the state, you could basically have state whatever it is, using like kind of a specific state of an asset and using that as collateral on an order book. And then you can borrow USDC against it. So truly cross-chain lending is going to be pretty cool. And then, something like restaking any asset on any chain, where you can actually manage kind of like the slashing conditions on the near chain. And then, essentially determine who to send the asset that you have slashed on whichever chain to, which could even be like a burn address, so that's really good. And then finally, we'll actually walk through this example of how you can build a Bitcoin ordinals marketplace in a trustless way. So to really paint this picture for you, let's imagine that we have a seller of an ordinal, a buyer of this ordinal, and we'll actually use USDC since there's not really any marketplaces yet that you can use USDC for. And then we're going to have this marketplace contract. And this marketplace contract is basically a near account, a smart contract near account. It's living on the near blockchain. So the first step here is the seller can basically ask the marketplace contract to generate a Bitcoin account that only the marketplace contract actually controls. Next step is the buyer can basically deposit USDC into this account on the near side. So now they can basically, both of them are kind of like funded. The seller can deposit this ordinal into this Bitcoin account that's controlled by the smart contract. So this interaction, depositing the ordinal, that's happening on the Bitcoin blockchain. What's cool now is that the seller at any time can ask the marketplace contract if it can withdraw the ordinal, as long as the ordinal is not in an active order. And the reason this is important is that this prohibits the seller from basically rug pulling a potential buyer if they have an open order. They can't just go and withdraw it because they don't control the account. They have to ask the marketplace contract to allow them to withdraw the order. So let's say they want to go ahead and list it for 10 USDC, and the buyer comes along and sees that, and they're like, okay, great, 10 USDC is a good deal for this ordinal. Basically, then what happens is before, only the seller can ask the marketplace contract to withdraw the ordinal. Now that right transfers to the buyer. So the buyer can now ask this marketplace contract to send that ordinal to some Bitcoin account that they control. And then on the seller side, the seller now can withdraw that 10 USDC that the buyer had deposited. And so this is how we can build, using these chain signatures, this truly trustless, or at least trust minimized ordinals contract. And you can extend this pattern to a lot of different chains, and especially these non-smart contract chains, even like Ripple or Doge or BitTensor for anyone who's into that. So there's a very, very broad design space here that we're pretty excited about. And so we the team just got some developer docs out. There's a lot of examples there. So on the, left here, you have the developer docs. So go try those out, give us feedback, let's see what we can build. And then if you want to join the Telegram group, we have a dev chat with all of the relevant people in there who can answer questions, and a lot of folks have enjoyed that. And that's what I have for you guys. So thanks everyone.